Assalamu alaikum. Today we will be discussing about the Avogadro's number. So first of all, let's define the Avogadro's number. The Avogadro's number is the number of elementary entities in one mole of a pure substance. So first let's talk about the elementary entities. So elementary entities are basically the constituent particles of a substance. The thing which constitutes, which makes a whole pure substance is called the elementary entity. For example, the elementary entity of carbon, or I can say diamond, will be carbon atoms, and the elementary entity for water that we see in bulk will be the water molecules, the H2O molecules. And now let's take some other examples of the elementary entities, and then we will see that how the nature of the elementary entities varies with the nature of the substance. So now let's take some examples from this table, and this table shows the first type of the elementary entity of the element. So what are the elementary entities of an element? The element is simply composed of atoms, so the elementary entity for the element will be atom. And if we take an example for that, we can talk about the diamond or graphite. We can call diamond or graphite as the elements because it's simply composed of carbon. There is nothing else in the whole structure of that. And the structure may vary, they may be allotropes of each other, but they are both the elements of the carbon. So the what will be the elementary entity? The elementary entity will be the carbon atom. And how many carbon atoms, how many elementary entities will be there in 1 mole of the diamond or graphite? It's just going to be the Avogadro's number, which is a well-known figure, that 6.02 times 10 to the power 23. And now let's talk about the molecular compound. If we take the pure substance as a molecular compound, we can take an example of water, as we have discussed earlier. Here we can take another example, and for molecular compound, the elementary entity will be the molecule. And for sucrose, as we see, the sucrose is a crystalline organic substance, and we see that the sucrose basically has the molecules C12H22O11. And and if we talk about the 1 mole of the sucrose, we will just find out that there are Avogadro's number of sucrose molecules in 1 mole of the sucrose, 1 mole of that molecular compound. Or there are many other examples of the nature of the substance, but because of the lack of space, I have just discussed the three. If we talk about the ionic compounds, then we can say that the formula units are going to be the elementary entities of the ionic compounds. And if we take as an example of the ionic compound, there is a well-known example which is table salt, the sodium chloride NaCl. And what will be the elementary entities in that case? It will be the NaCl formula units. And how many NaCl formula units will be there in 1 mole of an ionic compound, in 1 mole of NaCl or the table salt? It's just going to be the 6.02 times 10 to the power 23, which is the Avogadro's number. And if I say that there are this number of formula units in 1 mole of NaCl, it doesn't mean that NaCl molecules are there. On an average, we can say that in 1 mole, in that particular 58 about 58.5 grams of NaCl, there will be 6.02 times 10 to the power 23, or the Avogadro's number of sodium ions and the Avogadro's number of the chloride ions as well, and they will constitute a whole lattice. And that lattice is going to form, and that lattice will be the whole chunk that we see in our real life. So what we found from here, that 1 mole of different substances, the substance may vary, but the number of elementary entities will always remain the same for 1 mole of the substance. If we talk about 1 mole is a very special term. 1 mole depends, the mole basically depends upon the number of particles, number of the constituent particles, and the constituent particles are basically known as the elementary entities. And the elementary entity could be anything. It could be an atom, it can be an ion, it can be a molecule, it can be anything. So I hope you are understanding the thing. Now let's move to the masses. How can we define the mole in terms of mass? When we talk about the mass, mole is all about the amount of substance. And when we talk about the amount of substance in terms of number of constituent particles in number of elementary entities, we say that we are using the mole. And when we talk about the amount of substance in terms of the mass, in terms of the whole quantity, when at that moment we talk about the mass, so somehow we should equate the mass with the mole. And by the end of this slide, you will better notice that it's easier to convert 1 mole of a substance into its grams. So let's into its or we can say into its mass. So how much will 1 mole of a particular substance weigh? And there is a trick here, there is a different thing here. And that different thing is that the different substances, the 1 mole of different substances will have different weights. Let's talk about that. And we want to see that why does that happen. It's just because the each elementary entity of a particular substance, each elementary entity of a particular substance has different weight, has different mass. Since it has a different mass, so there will be the different masses of the whole chunk. Let's try to understand with some examples, and examples are given in this table. And if we talk about the substance, when we talk about the hydrogen gas, what's that? It's just a molecular substance. And when it's just a molecular substance, so what will be its elementary entity? Its elementary entity will be the hydrogen molecules. And what is going to be the mass of that hydrogen molecule? It's just the 2 amu, one for each hydrogen atom. And amu is basically, as we all know, is the atomic mass unit. And if we replace that amu with gram, if we take or in other words, I can say that if I take 1 molecule of hydrogen atom, it will have the weight of 2 amu. And the weight of 1 mole, which is far greater than 1 amu, will be the 2 grams. And that's what we all know, that in 2 grams of hydrogen, the molecular hydrogen, there will be Avogadro's number of the hydrogen molecules, because the hydrogen molecule is the elementary entity, and the number of elementary entities always remain the same in 1 mole of the substance, or we can say in equal number of moles of a particular substance. Let's take an example of water. The elementary entity in this case will be the water molecules. And when we talk about its molecular mass, the molecular mass comes out to be 18 amu. And I have calculated it for you. If you don't know, I think most of you will be well familiar that how to calculate the molecular mass. But and now we just need to shift that amu with grams, and we will get the mole. 18 amu is the mass of 1 molecule of water, and 18 gram is the mass of 1 mole of water. And in 18 amu there will be only 1 molecule of water, and in 18 grams or 1 mole of water there will be 6.02 times 10 to the power 23 molecules of water. So that much bigger is 1 mole than 1 molecule, or we can say an elementary entity, to be more precise, to be more general. Now let's talk about the sodium chloride, which is an ionic substance. And NaCl will be its the formula unit, or we can say its elementary entity. And its formula unit mass is going to be 58.5 amu. Now its formula unit mass is 58.5 amu, and if we take 58.5 grams of that sodium chloride, it's going to be 1 mole of sodium chloride. And there will be Avogadro's number of formula units in that 1 mole, or 58.5 grams. So I think you are getting the relationship between the mass of the substance, the mole, and the number of elementary entities. And now let's move to an elemental substance. The elemental substance can be the sodium metal. Sodium, although it is very hard to contain or retain the sodium metal in the form of, you know, the pure form in the elemental state, to protect it from the other elements, as it is a good reducing agent and there are many oxidizing gases in the nature. The major oxidizing gas in the nature is basically oxygen, and it can react with that, it can react with anything, and it will get oxidized. But if we say that we somehow we have pure sodium metal, it's the one atom of the sodium metal, the elementary entity of the sodium metal will be one of its atom, and the weight of one of its atom will be 23 amu. And what will be the weight of one mole of a sodium atom, or I can say one mole of the sodium metal? If we talk about one mole, we will talk about the nature of the substance. So what will be the mass of one mole of sodium metal? It's just going to be the 23 grams, and that simple it is. And from that we can conclude that one mole contains 6.02 times 10 to the power 23 elementary entities. That's what we are discussing from the beginning of this video, and that particular number is going to be the 6.02 times 10 to the power 23, which is, and it's going to be the Avogadro's number. And now let's talk about the mass of one elementary entity. Mass of one elementary entity is represented in AMU. So whenever we talk about the elementary entity, for example, if we talk about the hydrogen gas, the elementary entity is going to be the hydrogen molecule, and the mass of one hydrogen molecule will be represented in AMU. That's 2 AMU. But the mass of one mole of the hydrogen will be 2 grams. It's going to be represented in grams, and that's what I have shown here. We just need to keep the numerical value the same, and just replace the units with the grams, and we will get the 1 mole of that particular substance. So whenever we talk about a reaction, it's quite easy to take the grams, to take the substance in grams instead of AMU, which is a far smaller unit. And we will talk about that a bit later, that how much 1 AMU is smaller than 1 gram, and how is the number of elementary entities in a particular substance is going to be that particular number, the 6.02 times 10 to the power 23. And now let's talk about that how much, and that's what is the topic for the rest of the video. And how would we figure out that? We would simply figure out that how much is 1 mole bigger than one elementary entity. So we can just figure out by dividing the mass of one elementary entity with the mass of 1 mole of the substance. For example, if you divide the 2 grams of hydrogen with 2 AMU, what's going to happen? We will talk about that. And what would happen if we divide the 18 gram by the 18 AMU? And what would happen if we divide the 58.5 gram of sodium chloride with 58.5 AMU, and so on. Now let's move to the other example, and we will take the mass of the substance, and the mass of the 1 mole of the water we will take in the numerator, and then we will divide it with the mass of 1 molecule of the water. So what are we doing? We are just dividing the mass of an elementary entity with the mass of 1 mole of that substance. And for instance, the substance we have taken here is just the water, and we can say that 1 mole, how much will be the weight of 1 mole of water? It's going to be 18 grams. And what will be the mass of 1 molecule of water? It's going to be 18 AMU. Now we can write it like this. We can take aside the 18, and we can see there are 18 in numerator as well as the denominator. So we can reduce this equation to 1 gram over 1 AMU. Let's try that same thing with another substance, and the substance is the sodium. So now in this case it is a it is an element, and what will be its elementary entity? It's going to be its atom. And if we divide 1 mole of sodium, if we divide the mass of 1 mole of sodium by the one atom of by the mass of the one atom of sodium, it's going to be the 23 grams over 23 amu. The same thing is going to happen with that, and we will end up with 1 gram over 1 amu. So whatever the mass of a particular substance, whatever the nature of the particular substance, it doesn't matter. The ratio of 1 mole to the ratio of mass of 1 mole to the mass of 1 amu will always remain the same. It's always 1 gram over 1 amu. Now to get a particular number, we will we will need to figure out that how what is the 1 amu, how many grams are there in 1 amu, or we can say that how many amus, the smaller unit, the amu, how many amus are there in 1 gram. Well, it has been calculated, it has been figured out with some experiments, and we will talk about that experiment in next video. But you can take a hint from here, that you can find it with mass spectrometry. When we do the mass spectrometry, we usually ionize an atom. If that atom can be a hydrogen atom or any other thing, and when we ionize that, the change in mass is going to be almost negligible, because a proton is about 1800 times heavier than an electron. So there will be so practically there will be no change in the mass of the ion. So the difference of mass of an ion and the mass of an atom of a particular substance is just going to be the negligible. We will talk about that in another video. But now with experiments, we know that 1 amu is equal to 1.661 times 10 to the power minus 24 grams. And if we take that mass, the mass of 1 amu, we substitute that mass in the equations we find here, that if we divide the 1 gram over 1 amu, we will find out that how many amus will be there in 1 gram, and we will finally find out that how many elementary entities will be there in 1 mole of a particular substance. So this definition is may look a bit familiar. This is what we are talking about since the beginning of this video, and that's the Avogadro's number. If we divide the mass of 1 mole of substance by the mass of one elementary entity of that substance, what will we get? We will get the Avogadro's number, the number of elementary entities in 1 mole of a particular substance. That may be a bit harder to grasp for the first time, but if you ponder or think about that for a moment, you will understand what I'm saying. So now let's substitute the thing, and we can say 1 gram over 1 amu is equal to 1 gram over 1.661 times 10 to the power minus 24 grams. And when we divide it, when we when we simplify when we evaluate the equation, the ratio will tell us that how many elementary entities are there in 1 mole of the particular substance, and that's going to be the Avogadro's number. So now let's move further. We can say that 1 gram over 1 amu, this is the mass in the denominator, is 1 amu, and I have just substituted that. And if I take that thing, take the power factor, 10 to the power 24 minus 24 in the numerator, it's going to be positive. And what will be the reciprocal of 1.661? What will be 1 over 1.661? And it's just going to be the 0.062. The reciprocal of 1.661 is 0.062, and when we will move the decimal point towards the right, what will we get? We will get the 6.02 times 10 to the power 23, which is the well known figure for the Avogadro's number. So I hope you will you have enjoyed this video, and you will understand that how one mole of a particular substance has the Avogadro's number of elementary entities. So that was just an intuition. That's not whole proof for that why the Avogadro's number is equal to 6.02 times 10 to the power 23. I've just tried to explain with an example or with some examples that how it's going to be equal.